We're going to begin today with a brief overview, an introduction to Astadia and Abbey Road software. We'll spend a few minutes talking about our phased approach to legacy modernization. And then we're going to turn the program over to Abbey Road software for a closer look at their MAPPER 2 Java technologies. Then we're going to spend just a minute or two talking about how to get started, how you might want to engage with us, and of course we're going to leave plenty of time for questions. And I know a number of you got in here early. We already have 3 questions in the queue, so please keep those questions coming, and we'll get to them at the end of the presentation. Just a quick overview on Astadia. You know, we're a technology and cloud company, services company, and more specifically, we have just over 25 years of experience with complex legacy modernization projects. In fact, we completed our first project all the way back in 1994, and since then we've done work in just about every industry vertical and for many government agencies. And we're really pleased to be partnering with Abbey Road software on this MAPPER to Java solution, because it really enables the two of us to provide a complete end-to-end solution to the Unisys installed base. Abbey Road software was founded in 2010 by a team of industry executives from companies like Software AG, the Unisys 4GL management team, and Zulu Software. Their MAPPER to Java technologies are built on a proven modernization model, and they developed this technology because the demand for MAPPER solutions is so high, you know, especially now with so many people wanting to move to the cloud. Our speakers today are Craig Marble, Solutions Director of Legacy Modernization at Astadia, and he'll be joined by Dave McSwain, co-founder and CEO of Abbey Road Software. So Craig, the presentation is yours.
Great, thank you. As you may recall, for those of you who have been joining us before on our webinars, we've done a series, and we just wrapped up a series about legacy modernization, starting out with how to prepare for your modernization project, covering things like doing the research and analysis on your portfolio, determining how you want to move forward, doing planning and design, things like that, moving on to executing the project itself. Code remediation, data migration, process modification, and determining what kind of modernization approach you want to take, whether it's a migration to a new platform or perhaps a package implementation to replace your legacy application, or a rewrite, or maybe something like a transformation where you transform the code from one language to another. And then we moved on to testing, and that is the process of testing your modernization, modernized applications, the training and education that goes along with it, and then the different pieces that go with implementing your project to make sure that it is a successful project. And all throughout our process of modernizing, we talk about sort of a holistic approach to your entire environment, not just the application themselves, but also the ancillary systems, the printing and the monitoring and the development environment and the production, failover, disaster recovery infrastructure, output and content management security. All of these pieces are important to take into consideration when you are undertaking a modernization project. So it's really a holistic approach. So as one of the things we were talking about in this series was an approach that included transforming code, so taking legacy code and transforming it into a different language. So we have partnered with Abbey Road software to undertake projects to take MAPPER applications from the Unisys platform and convert them into Java. So this is going to be a very interesting seminar on that process, which supports the transformation approach to modernization for one specific aspect of your Unisys environment. And with that, I'm going to hand it over to Abbey Road Software and Dave McSwain.
Yeah, thank you, Craig. Good afternoon, and thanks to everyone for making time to join us today. We're looking forward to some lively Q&A at the end of the session. It's good to talk about one of our favorite topics. So we're going to introduce to you today something we call MAPPER to Java, cleverly named product. Marketing guys came up with, and we're going to start talking a little bit about the approach and the technical architecture and the way we tackle this challenge and the results that you could expect using Abbey Road. What problem do we solve as an overview? Significant costs, ongoing costs, and difficulty to maintain both, in many cases, a Unisys mainframe and a MAPPER environment. If you talk to people like Dale Vecchio at Gartner Group, he'll tell you that the most challenging aspect of maintaining a MAPPER type environment is human resources. Where do you get the people? And there are not a lot of new people coming up as the older bucks finish up and retire. So how do you support these environments from a human resource, a people skills point of view? How do we do what we do? This is automatic transformation, which is one technique, as Craig said in his wheel, for taking language A and moving it to language B. Basically, what we built is a big compiler that ingests the MAPPER code and then, in turn, produces Java with relational database tables and SQL calls. What is the value of this product and service that we have to Unisys client? Essentially, it's a migration to the cloud to get them to a cloud-ready technical environment. And it's over time, it's a phased-out approach to reduce cost and take advantage of the skills that are out there in the world of Java. So what is M2J? It's really a set of programs that transform MAPPER applications to Java Enterprise Edition. We take the MAPPER application and we make a N-tier architecture application in Java out the other side. So the N-tier approach is common in cloud computing in most modern IT environments, as I'm sure most of you already know. The presentation layer is handled completely by a web browser. And the data entry and display is done through Ajax-based technology to emulate the migrated application screens. So here's a picture of what we're doing with MJ. Essentially, we're taking the conversion that occurs in the migration and move on the left-hand side over to the right, where there's a mitigate and maintain phase that moves on to an enhance and evolve phase. That's the approach and the life after migration that we recommend. So the code that comes over is computer-generated Java code and computer-generated SQL, and then over time you can begin to move those pieces into a different form as you see fit. Here's our reference architecture for a migrated MAPPER application. So MAPPER organizes artifacts into a model similar to an office filing system of cabinets, drawers, and reports. And whether a MAPPER artifact is a stored program, a run, if you will, a configuration store, or screen or data, it is stored as a MAPPER report and sometimes known as a RID, or report identifier. M2J migrates MAPPER reports that contain data to relational database tables, and as illustrated, M2J produces multiple artifacts as a result of this translation of a MAPPER report to a database table. The migrated data would appear as a database table in a relational database. SQL DDL that creates the new database table is furnished by MAPPER to Java. A Java persistence class that is object-oriented representation of the entity, as in an entity relationship modeling form, and the entity data in the MAPPER report. Hibernate mapping between the database table and Java persistence class. Data lines in the MAPPER report are extracted to a CSV formatted file and loaded into the new database table using Scriptella, ETL, extract, transform, and load, with Scriptella being an open source facility. Translation of MAPPER reports into database tables is informed by configuration items based on the Java Spring Framework. M2J generates default configuration, can then be fine-tuned manually. Once migrated, entity data is managed by the popular Hibernate Object Relational Mapping, ORM package, some of you might be familiar with. It performs all of the so-called CRUD operations, create, read, update, delete operations. And those can be performed on the entity data using Hibernate and any related generated persistence classes. So parsing mixed commands, output area, and data, MAPPER runs. What's going on there? So MAPPER is unique in that a MAPPER report may contain a mixture of data, commands, comments, literal output similar to print statements in other languages, screen layouts, and calculations. M2J recognizes each kind of construct in this mixture, and it processes and analyzes those constructs to translate them into the Java language statement. So that's what's going on here in this sequence of component interoperation. The M2J parser recognizes and classifies the lines in a MAPPER report. Lines that contain MAPPER commands or data are further processed by the M2J lexer to produce a parse tree. So things like @ART, @CHG, @DC, @TOT, and @CAL expressions and @SC directives are also parsed. The MJ analyzer examines control flow specified by MAPPER commands. So examples would be @GTO, @RSR, @call, @return, and @LNK. And variables that are declared by an @LDV, an @LDA, or inline to create a control flow graph and symbol table. Using Java's code model library, the M2J code generator creates Java language statements that are wrapped in Java servlets, or JSPs, for Cool Ice native services. I'm going to talk a little bit about Cool Ice here in a minute. M2J record projection. M2J supports a feature known as record projection as an aid to migration. M2J record projection adapts line and buffer-oriented I/O that's found in MAPPER programs to the object relational model common in modern J2EE applications. MAPPER applications may contain commands such as @RDC, @FDR, and others that retrieve and traverse lines of data from a MAPPER report. Fields in the line are extracted into variables either by field name or position. M2J migrates MAPPER data reports to relational tables and MAPPER fields to database columns. Record projection fetches rows and columns from the relational table and then formats the data as a line. This allows MAPPER, migrated MAPPER code that extracts data by position to function correctly. Record projection also propagates updates made to align to the proper row and column in the relational table. Okay, M2J GUI architecture. So what's going on with the GUI? MAPPER statements such as @SC and @out and @DSP send display data and commands to green screen terminals. For example, @SC's DL screen editing directive deletes a line from the screen, while the @SC's MSG directive displays a message or a prompt. M2J will emulate these capabilities using browser-based client-side technologies like AJAX and GWT, the Google Windows Toolkit, and server technologies like Comet and JMS. So that's what's going on here. Unlike event-driven GUIs, MAPPER programs write output or display a form to the screen and then wait for input data or a function key to be transmitted from the terminal. Any migrated M2J applications employ queues and HTTP to simulate this behavior. Output data and directives issued by the server-based M2J application are queued for rendering in the web browser. Input data, form actions, for example, @SC DSP form, or page FT actions, and function key events, for example, @SC key action, are collected from the web browser. After that, they're sent to the server and queued for processing by the waiting M2J application. So here's a picture of a screen that has been processed, and this is the original screen that's been processed into a converted screen, which I'll show you in a second. And you can see that this was a screen from a real-life application before transformation. So here's the migrated green screen. So the same form converted to AJAX, web-based technology. So this can be used with the browser of your choice, Internet Explorer, Firefox, Chrome, what have you. While the form looks and acts like the original green screen, it is accessible from the cloud. So this is a pure thin client-based approach to transformation of the original green screen MAPPER displays. Okay, so here's the cool ICE stuff, M2J and the Internet Commerce Enabler, aka ICE. Native cool ICE services are migrated to Java Server Pages, JSPs. There's a natural fit there since a native ICE service is backed by a web-centric MAPPER run. M2J migrates MAPPER runs to Java servlets, and a JSP is compiled into a servlet. This is option 1 in the diagram. A bracket notation, that is square brackets, used for HTML tags to avoid confusion with MAPPER-named variables in older ICE applications. That's converted to angle brackets at migration or runtime by the servlet filter. To convert bracket notations during migration, something called a pragma may be required to clearly identify named variables if the variables cannot be determined by the context that they sit in. There may be instances where ICE is part of a larger ASP application. This architecture introduces complexity, including in the original web application, that may be handled in a couple of ways. So you've got two options here. Number one is the host web application under under JEE, converting ASP to JSP using tools such as J-ASP, netcool.com, and ASJ to JSP, diamondedge.com. Option 1 in the diagram. Option 2 in the diagram, convert an ASP to a JSP for select or all pages, but keep the IIS, the Microsoft Internet Information Server, using the IIS-Tomcat redirector to execute the JSPs, option 2 in the diagram. In the cases above, open ICE service ASPs converted to JSPs emulate the ICE ASP object via Java beans. The URLs to native services and data services are wrapped in tag libraries is how that gets processed. For web applications using open ICE services and the ICE ASP object that must remain under IIS, the ICE ASP object must be emulated. So there we use C# and .NET COM assembly that uses web services to invoke native services and data services. This, again, is option 2 in the diagram. How do I get started? I'm turning it over at this point, and sorry, skipped ahead here. Turn it back to Greg.
Okay, Dave and Craig, thank you. Thank you very much for that presentation. We've got plenty of time for questions, but before we get to those, we'll do that in just a minute. I'm sure a lot of you are just wondering, okay, how do I get started with this? You know, what's the next logical step? And what we really suggest that you do is contact Craig Marble at Astadia. He was the first speaker that we heard today. His email address and phone number are up there on the screen, so it might be a good idea to kind of jot those down on a piece of paper. It's essentially an introductory kind of a conversation. You know, Craig will you know, ask you some questions to help you help us and you kind of assess your environment, and from there, you know, he'll help you understand how Mapper to Java can work for you. And part of that conversation is he's going to ask you to start thinking about, you know, a Mapper application that we might be able to use down the road as a proof of concept demo. So again, that's kind of your first step. Something you can do right now, if you're interested in learning a little bit more about Astadia's approach to legacy modernization projects. We've been running over the last couple of months a 4-part webinar series that we call a phased approach to legacy modernization. So far, the first 3, one on preparing for the project, one on executing, and finally one on testing and implementing, as Craig mentioned a little bit earlier. Those are complete on-demand versions of those webinars are available at astadia.com under the Insights tab, and you'll see them right there. The 4th webinar in that series, The Value of a Legacy Modernization, is scheduled to go live October 19th, which is just 2 weeks away. So be on the lookout for invitations to that webinar. And finally, one last thing. As participants of this webinar, we're making a special offer, and that is that once you've talked to Craig, you know, Craig will assemble a team from both Astadia and Abbey Road Software, and we'll set up a call with you and, you know, any members of your team that you'd like to have on it. This will be a very, very consultative sort of meeting where we're going to ask you to tell us as much as you can about the challenges that you're facing, what your plans are, what your goals are, what you're trying to accomplish. During that call, we'll provide a much deeper dive into Mapper to Java and give your technical teams a chance to ask Dave and his team, you know, basically any questions that you'd like to ask. And then from there, we'll develop a strategic go-forward plan that, you know, we'll present to you. Hopefully by then you will have selected a Mapper application that we perhaps can use as a proof of concept, and we'll move forward from there. Again, Craig Marble's email address and phone number are at the bottom of the slide. At this point, guys, I'd like to move into questions. We still have 3 questions in here, and Dave, you had mentioned that these might be best answered by your Vice President and Chief Technology Officer Scott Adams. Scott, are you on this call?
I am. Yes. How are you?
Excellent. Wonderful, Scott. We've got 3 questions waiting in the queue right now that we're hoping you can answer for us. The first one is, how do you handle Mapper's calculate command?
Okay, so we're starting off with an easy question, apparently. Yeah, that actually is a good question, and that's one of the most complex commands in Mapper. So, and one of the things that you know, Mapper is known for is it's very succinct. You know, you can do a lot of things in a few lines of code. Now, a calculate command tends to have a lot of additional things. The actual command itself, cal, is short, but then there are these expressions, conditionals that actually do the work. So when you're in Java, you don't really have the same kind of expression language built into Java. So what MJ does is we have the idea of formulas, and we use this for art, change at DC as well. And what it does is it allows us to carry forward some of that succinctness of an expression that's, for example, embedded is part of the instructions of how you process a result set using CAL. So that's one key part of this, is this idea of formulas. Now that's not something we modified something called Spring, which Dave mentioned. That's a standard lightweight framework in the Java world, and there's something in there called a Spring expression language. So we've based our formulas off this kind of standard Spring expression language. So that's a key part of the component. I can go on. There are also some Java patterns we have to apply. Iterable, to iterate through the result set. The idea of decorators for things like summing, average, min, and max, using what we call the vertical functions. Record projection, which Dave touched on, comes into play, and that is actually a large topic in itself. Context, for example, you need there's the idea of you're actually on a row, and a row has a line number, which is once again another thing we could segue into here. How do you handle line numbers, which are very prevalent in a MAPPER application? How do those carry forward into an MJ application? So that's a long-winded answer, but it's a long-winded topic.
Okay. All right, Scott. Thank you. Second question. Do you support other relational databases as target platforms for your MAPPER 2 Java output?
Yes, we're agnostic. We've been targeting Oracle because it's got a high penetration in the enterprise space. But since we're using Hibernate for object relational mapper, it has a number of other dialects. For example, you could do SQL Server. You could do something like Derby. You could use MySQL. There are a number of options there.
Okay, good. And right now, just one last question. Does Java run on Windows with the same JVM interface as other operating systems?
That's correct. You can get a JVM that runs fine on Windows from Oracle. IBM sells variations of that old Sun JVM that they've enhanced that can be run on commodity hardware. So yes, the question is absolutely yes. Now what we recommend, and once again this is commonplace today, is you want to have a 64-bit JVM. If you have some 32-bit machines lying around, well, those are fine for development. But for anything serious in production or performance testing, something like that, you definitely want a 64-bit JVM.
Okay. All right. Okay. I don't think we have any other questions coming in. I'm just doing one last quick scan here. Oh, wait a minute. Yeah, we do. Sorry, question from the audience again. How are result RIDs handled in the new framework?
RIDs are handled using... Okay. Yeah, that's right. So the idea in MAPPER is, you got these reports. Everything's a RID, right? Could contain a run, could contain a screen, could contain data. And what MJ is doing is converting what I call the data reports to a relational database. And you can query that relational database with a search or a binary find, and you can get a result out of it. And there are other ways to get results. So what we do there is everything, since it's Java, everything is a class. But you have a collection of classes. And we leverage something which really should be on one of these slides, but it's not, called CQ Engine, which is a very fast, efficient way of actually representing a collection of objects. Once again, we're in the Java world now, trying to bridge that gap between Java and MAPPER. And we can search using, actually you could search using an SQL dialect, but you can search using some, sort of like, algebra, I'll call it, that collection. So the search features that work on a MAPPER report and work on a MAPPER result set can be carried over to Java. I hope I answered the question.
Okay. All right. Scott, we got two more have just come in. The next one is, how are line types handled?
Yeah, the line type is actually preserved, because I think that's something we just have to do. So there's a concept. If you go back to slide, I think it was 11. It talks about the process of migrating from MAPPER, which once again is very succinct. I know it served a lot of these organizations very well, but we're trying to get to the cloud, which is easy to do with another technology. Yes, slide, the one that talks about the three kind of phases.
This one here?
That one, right, yeah. So when you migrate and move, we retain the line type. Now that could be enumerated if it makes sense. For example, if you have multiple line types that somehow convey information about the type of record, we actually can create what's in Java is called an enumeration. So you can kind of have a better representation of what that is. This is an order that has been fulfilled. This is an order that is backward, something like that. Or you can just store the actual line type character itself. But it gets stored in something we call a shadow table. So we take the rows, and it could be trailer lines, which typically represent a different entity. We take the rows that represent entities and we convert those into a relational database, and they're represented in Java as entity objects. And the line type is stored in a shadow table that joins to that table. The idea is, after you've migrated the application, you run it for a while, make sure it works. So you're going to have this shadow table, but then as you evolve and enhance away from some of those paradigms that came over from MAPPER and refactor some code, you can drop that shadow table. So the line type pretty much goes away after a while. Now, it doesn't have to. You continue to run that migrated code, the MJ code, as long as you want to. But I think most organizations eventually will get to this enhance and evolve phase where you remove things like the shadow table. It's an artifact of the migration.
Okay. Okay. Next question, Scott. Does it handle line continuations in the MAPPER code, or does each line need to start with the @ symbol?
Now you can cram. Of course, we probably don't want to do this in the 21st century. We probably didn't want to do it before the 21st century, but you can cram all your MAPPER commands on one line if you want to do that. We would actually parse that.
Okay. Okay. And the next question is, how is code with looped, and I'm sorry if I get this wrong, looped @RLN handled?
A looped line read? I assume that's a looped line read by line number. So yeah, the line numbers are tricky, are tricky in MAPPER, and tricky to migrate. So what we do with the line numbers, really, I think it's this conversation I alluded to, is we carry them over as well, but we carry them over as, they obviously have to be concrete numbers, but we carry them over for the purposes of having them be relative positions, and they're carried over in the shadow table. So if you had 10 lines in the MAPPER report, the line numbers would be 1 through 10. But actually, when that gets loaded into the shadow table, the actual entity data gets loaded into a relational database table. There's a shadow table that joins to that. The line numbers are spaced. So that line number 1 becomes maybe line number 500, and the next one is line number 1,000. And what it allows you to do is you have gaps. So what we're interested in is we can still seek to a line number. So once again, you can have a concrete value like 500. But the main thing we're interested in is going back and forth, right? Traversing by line number. You can increment the line number, you can decrement the line number, but so when you add to a line number and then actually seek to it, you're really saying advance to the next line. So if someone's actually adding 3 or 4 to a line number, yeah, those kind of things can be tricky to deal with. We would only recognize that as you're trying to advance to the next, the third row, as opposed to, line number 1 plus 3, which is 4. So we've taken the absolute line number. We're trying to treat it as a relative thing. Advance 4 rows versus, just go to line 4. I don't know if I answered the question, but I certainly tried.
Yeah, no, that sounds fine. That sounds fine, and hopefully, if you didn't, the folks will contact Craig as we had suggested near the end of the presentation. Scott, the last question is really not so much a question as it is a request, which was to display the agenda slide one last time. So that's why I'm moving backward through the deck here. Yeah, at this stage of the game, folks, we have no further questions. So I really do appreciate your attention. We greatly appreciate your interest in your questions, and we look forward to talking to you real soon.